Good morning. We're going to take probably a little bit of a different direction with my talk, but I'd like you to link it back to the previous scholars' works to think about how the content underlying all of their presentations, in some respect, women are obscured or elided from access to that content through what I'm going to talk about, which is social science, digital media, and science phobia. And I'd like to start with a clip from one of my favorite shows, which is The Big Bang Theory. So Nick, if you couldn't mind helping me with that. I'm sorry.
Some science. Me too. Okay, I am Dr. Leonard Hofstadter. I am here with my friends, Dr. Cooper, and real-life astronaut Howard Wolowitz. And we are going to show you girls how cool a job in science can be. How cool, you ask? Well, how about negative 273 degrees? Because that's the temperature at which entropy reaches its minimum value. Did I just learn something new and have fun doing it? What? All right. So now let's bring out theoretical physicist Dr. Sheldon Cooper.
Hello, female children. Allow me to inspire you with a story about a great female scientist. Polish-born, French-educated, Madame Curie. Co-discoverer of radioactivity, she was a hero of science until her hair fell out, her vomit and stool became filled with blood, and she was poisoned to death by her own discovery. With a little hard work, I see no reason why that can't happen to any of you. Are we done? Can we go?
Okay. We learn how to turn the clicker and change the slide, it'll be good. So we'll go past that. So I want to talk about what my work right now, and just to give you a little bit of background, I was a bench scientist for many years. I decided that scientists at that time was not creative enough for me. I moved into informal science education, got my PhD in media studies, and here I am today. So I wanted to talk about Brotman and Moore's 2008 paper, which basically reviewed the work from like 1995 to 2006 of ways we need to engage, or ways that people are thinking about engaging women with science. So you can see here that there are two themes that I'll talk about. First, that when we looked at the issues of women in science, it was a focus initially on equity and access, that there were gender disparities and inequities in the classroom in terms of, if you just, as you just saw here, we're going to go have fun with science, and we're just going to teach you about, you're going to be Madame Curie, and you're going to vomit, and that's going to be great, and now can I go now because I'm done teaching women about science, kind of idea. Another theme that showed up in the literature was this issue on focus on curriculum and pedagogy, in the sense that we needed to change curriculum and pedagogy to recognize that it needed to include the experiences, learning styles, and needs of women. So these are the first two themes that they identified in the literature. Then we see two more themes. The first one here is the focus on reconstructing the nature and culture of science, thinking about how science is portrayed and viewed, the way we understand science, so we can talk about the perceptions, for example, of science, such as Nanette talked about in some way in her talk, the perceptions of what you hear and what you think you're going to hear, and a focus on identity in terms of supporting girls and incorporating science as a component of their diverse identities of people. So these are the four major themes that they identified in the literature in terms of ways we needed to think about correcting science for women. So I wanted to just talk about my work that kind of is an evolution from being a bench scientist and really believing, like Sheldon, that, and I could talk about entropy, and it was really cool, and that was the way to talk about science, and of course you're all going to get excited and follow me into the lab, to kind of my current perspective, which we'll discuss in a few minutes. But I wanted to give you some of my background, that I have gone from being a bench scientist to go becoming a distance educator, teaching K-12, so teaching online courses through Liberty Science Center in New Jersey, teaching courses such as biology, math, and earth science, to then moving towards courses at Rutgers University, where I teach junior, senior colloquia, small class sizes, 25 students. These are students who are quasi-scientists in that in some way they're going to have to deal with science in their careers, but they don't take science courses. And Rutgers, as in the tradition of many large universities, their beginning science courses are used to weed out students rather than incorporate students into science. So you take Bio 101, and basically it's to get you out of science and send you somewhere else, because we don't want the 800 students in this class all to descend on to the science program. My courses currently that I teach are Environment and Health in Science, Society, Mass Media, and Communication in the Life Sciences, and I deal with issues from the scientists communicating within the discipline to science being communicated to the public through mass media. And then I'm also working on a new project on looking at alternative pedagogy, and these are postgraduate. These are students in college, years 1 to 4, so it could be freshmen to seniors. And we're looking at digital filmmaking as a way to bring students into science by having them being part of a project, which is taking film shot in Antarctica and turning it into PBS films, giant screen films, and online clips. So what comes out of Brotman and Moore is the idea that there are things that are wrong with science. And these wrong things are issues of equality and access, curriculum and pedagogy, nature and culture of science, and identity. That science itself is inherently wrong. The way we teach it is wrong, the way we approach it is wrong. Well, I want to talk about what's right about girls and women, and then link that back to what can be right about science. Now, as I said, when I started in science, I was very much the bench scientist. It was very important to me to have rote facts. I did really well on all my little sheets. I could fill them in. I love film strips. I love to have that content. I loved to be the person who could be the little professor and tell you all about entropy and tell you all about fractals. But I didn't really think about the fact until I had been in science for a period of time that science is very creative, science is very collegial, and science is very communicative. Scientists don't work in a linear fashion. Holly pointed that out to me. We had this discussion this morning about this, and I thought I wanted to incorporate in the talk that we tend to think of scientists as thinking very linearly. They have a question, they do along some pathway, they get an answer. And if you ask students, and I do this, I've done this for several years now in my class, if you ask them to define the scientific process, they define it in just that way. If you ask them to think about what scientists look like, they define them in a certain way. And they have a misunderstanding of what science is because it's the way it's been presented to them. Having been a scientist, I recognize that science is really about iteration. It's never about getting one piece of data that cures or solves everything. It's about asking questions over and over again. And sometimes as you ask those questions, it takes you a very different direction than you actually thought about. Think about it like going on the internet. You go on the internet to find a piece of information, and when you leave the computer, you're in a totally different space that you were when you started. And you're like, how did I go from looking up how to get to my favorite restaurant to seeing what was happening on Saturn? You just don't even understand your thought processes because it's a lot of circular back and forth, and things lead you from place to place. And that's really what science is. So when we think about what's right about girls and women, what's right about girls and women is that we tend to be communicative, we tend to be collegial, we tend to be creative. And I'm not saying that men aren't communicative, creative, and collegial, but we're talking about women today. We're talking about what we need to do to encourage women and girls in science. So if I asked you to draw a scientist, what would your scientist look like? And I'm looking, anybody just want to yell out an answer? What would your scientist look like if I asked you to draw a scientist? White male. So the response was white male. Typically, this Draw a Scientist test has been going on since the early 70s, and it has looked at when children start developing their stereotypes about science. So if you ask a child to draw a scientist, this is typically the kind of response you see, that females tend to draw their scientists in this laboratory setting with images of content. Males tend to draw their scientists as male. Females draw both male and female scientists, and males tend to draw them with kind of these stereotypes of technology and these myths of science. A lab coat. Typically it is Einstein. He usually has big hair, big frizzy hair, crazy smile, glasses, lab coat, white male, typical. So if we ask, this is what you might see if you ask a child to draw a scientist. You get this kind of crazy-eyed guy with a test tube or a beaker or whatever. In this case, he's really happy looking. But what if you then take your students to a place and you allow them to interact with scientists and you allow them to see what scientists do? Here's an example from a Fermilab study where you had the before and after picture of a girl who had gone and interacted with scientists, and suddenly her perspective is quite different. And in my interviews with students in my classes, what I find is that if you allow students to interact with scientists, one of the most common comments I get is, "Oh, they're just like real people." And I always want to say to them, I guess that makes me something unreal, but it's okay. So anyway, this is a Fermilab study. Before the field trip, 36% of the girls drew female scientists. After the visit, 57% drew a female scientist. Before the trip, boys do 100% male. After the trip, they do 100% male. And that's okay, but the point is that what we're seeing is that women are starting to see themselves in a place. They're starting to recognize scientists. So part of that collegiality, that communication, helps to bring women into science, and it recognizes that we can see ourselves there. So I want to take you, just from my experience, what I've been dealing with is going from the kind of, this is a Krebs cycle, for those of you who are familiar with that. It's the pathway that's used by the cells to create energy. From my typical kind of science background, that would have been what I would have done in my science class. That would have been what, when I'm talking to students about science in my courses, I would have been talking about the Krebs cycle. And what I've gone to, because of the experience that I've recognized science has to be creative, science, well, it is creative, it's collegial or communicative, is I start using activities like these in my class. So we do science nursery rhymes. We actually turn nursery rhymes into science discussions, and we have to use science terms to rewrite the nursery rhymes. So students can see that science is just words, and once you have some way to understand the words, once you know how to communicate, you're able to understand and listen to people. And especially young women, if we turn it around and we give them the nursery rhymes, if I give them nursery rhymes, it tends to be the young women who can recognize the nursery rhymes more than the men. But it's an access point for them because they say, oh, it's just words that I may not know, and it's words that I can figure out, and it allows me to feel comfortable with science, because that is a fear point for science. We do a lot of YouTube videos. There's some great rap videos on evolution, on climate change, and we'll be encouraging students and working with students to actually start incorporating them, creating YouTube videos about science. When they start seeing their peer groups talking about science in a way that they can relate to a rap video better than they can relate to a chart of the Krebs cycle. Again, they don't see science as fearful and something different and strange for them. I do a lot of iconic images where students identify images and we discuss and analyze imagery to help them understand what are the things that they think science is like. So again, that's the draw scientist. When you start seeing students in a class and you have half boys and half girls, half men, half women, and the men all draw men scientists and the women draw some men and some women, you put them on the board, they start to rethink their perceptions and their beliefs about science. We do a lot of Twitter work where students go online and they're working in social media to see how and what people are communicating about science, and then they find themselves using that again as an entry point because it's a medium that they're comfortable with, social media, and it provides them the means to communicate or to look further down the road. It gives them a small amount of content, and then they can go further and look at it. We do a lot of mass media work. We use advertising. We do a lot of different things. We look at newspapers. We look at magazines. We look at books. We look at films. And we start trying to get students to see that science is often embedded underneath a lot of what we deal with every day. And that embedding, that presence in their lives, again, is an access point for them, which they now have through the work with the science nursery rhymes. They understand how they can work with the language. They become more comfortable. We're working into filmmaking. As I said, we have this NSF-funded project that is taking film that was shot in Antarctica over Christmas, working with the scientists who've been studying long-term change of climate change in Antarctica. We have, in the interviews that we're doing right now, students are coming in to say, I didn't think I could do this. I didn't understand what was happening, but now I see that scientists are really passionate. And the word that's so fascinating that's coming out of these interviews, they're saying scientists are really creative. And again, scientists are normal people just like everybody else. And we're doing storytelling where students have to write stories about science. So what I'm all leading to with this is that by linking science to daily life, by showing students how science underlies a lot of what they deal with, a lot of their personal interests and their social needs, building on the fact that college students tend to have a real strong desire to be part of a changing world or change the world, that science no longer becomes something foreign or alien to them. We do a tremendous amount of group work, again, because we want to build on this idea of science as being collegial, communicative, and creative, not science as being rote facts that you have to memorize. And I want to just, I was referenced an organic chemistry professor I had here who helped me survive my second semester of organic chemistry because he came to class, he would come to class, he would cross-country ski to class here at Mount Holyoke, and he'd come in his knickers and his cross-country shoes. But he told us, no organic chemist memorizes all the formulas. They have a book. Don't get so crazed about memorization. Just know how to use the content. And that was an entry point for me to see I didn't have to be the Krebs cycle. I could be this other person who knew how to access content. So the outcomes that we've been seeing in the classes so far is that students go from science fear to science comfort. Students go from science avoidance to inclusion of science in everyday life. Science activism. They start writing letters. They start getting involved in programs on campus. They understand that science is creative and they can see themselves as being able to create in science, that they don't think it's something that they can't do. Again, they have a lot more access points for science. And importantly, that science is possible. So what's right about science? Going back to Brotman and Moore, these four themes that have been shown in the literature as we talk about science pedagogy and encouraging women in science, I'd like to add one more. And I'd like to add that the social nature of science, the collegiality, the communication, the creativity are critical for us to consider as we communicate science. So for those of you who talked about science today and those others, you've already been talking about a lot of these things. And I think that that's what's showing up in my work, and we're hoping that it will continue to show up in our research and our studies over the next few years. Just real fast, one last thought. I just want to point out, this is a chart from the Six Americas study by Lasarowitz et al. It's a consortium of universities who are looking at perceptions of climate change, and they've described the fact that there are 6 Americas who go on the scale from highest belief in global warming to lowest belief in global warming. And what I wanted to leave you with this was because what they said was, you can't necessarily reach everybody, but you can reach the people who are waffling. You can reach the disengaged and the doubtful. And it may be that not every woman and every girl will come to science and appreciate it, but maybe if by changing the way we introduce and teach science, we're going to get those disengaged and those doubtfuls, and that's not so bad. So I'd like to thank you for your time.